All right, in this video, I'm going to do a couple of problems relating to interest, specifically compound interest. I'm going to be talking about two types, uh, compounded and a similar but related type, continuously compounded interest. So we've got a couple of problems here. The first one is at the top, second one's at the bottom. So let's call this, problem number one. And down here, we'll get to this later, problem number two. So the first problem, if you have $4,500 invested in a bank account, at an interest rate of 7.3% per year, find the amount in the bank after 11 years. If interest is, now this dot, 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 let's continue this statement. Uh, let's say part A, 1A, compounded annually, right? Part B, compounded quarterly, and part C, compounded monthly. And then in part D, I have it over here on the right, compounded continuously. Now, the reason I have it over there on the right is because we need a different formula for continuously compounded interest. Okay, so like many problems in math, you can't do this problem. You can't even attempt to solve this problem if you don't have the appropriate formulas. So you either have to have them memorized or be able to look them up or find them in your notes, or if you like a challenge, try to derive them on your own. But we have various unknown quantities and known quantities that we have to work with. And the formula, the equation, is what relates them all to each other. So we've got $4,500 is invested, right? We call that the principal amount, the starting amount. Okay, then we've got an interest rate of 7.3% per year. So that's going to be our interest rate. Okay, so let's record this stuff as we go. P, the principal, is the 4,500. Right? Lowercase r, the interest rate, that's the interest rate. Let me highlight this part as a decimal. You cannot use 7.3 in your formula because 7.3% is not a number. It's more of a description. So to convert that to a number, you divide by 100 to convert it to a decimal. So that would be 0.073. Okay. Then we've got find the amount in the bank after 11 years. Right, well, that's our time. After 11 years. So T is equal to 11. And what we're looking for, find the amount in the bank after. Let me include the word after in what I'm underlining in green because the future amount, the future value after some time has passed, right? So that is what we are looking for. So A is the question mark. Okay, so here are our five variables, our five amounts, right? So we've taken care of four of them so far, the P, the R, the T, and the A. But then we've got this N. This is the number of compounds per year. Now, compounding is when you're, how often your interest is calculated and added on to your current balance, right? So we've got annually, quarterly, monthly, and continuously, right? So over here, N is the number of compounds per year. N is the number of compounds per year. So now let's establish the formulas that we're going to be using or the equations that we're going to be using. And so it depends on which type of interest we're using. And I'm not going to explain the different formulas and the different types of interest in this video. I just want to work through the problem. So assuming this is something you've already covered or you've already seen, we've got two different formulas for future value. For A is the future value. That's what we're looking for. If your interest is compounded annually, semi-annually, quarterly, weekly, monthly, daily, we use the same formula for each of those. That's P, that's the principal, times 1 plus R over N raised to the power N times T, right? And if the interest is compounded continuously, that's the one where we're using the natural exponential base, the number E. P times E raised to the power of R times T, right? The exponent is only affecting the E, right? Exponents first and then multiplication. So P times E to the RT. Okay, so let's see what we're plugging into our formulas here. Let me switch back to blue. Compounded annually, that means once per year, N is equal to 1. Compounded quarterly, if the year is split up into 4 quarters, N would be equal to 4. 4 quarters in a year. And compounded monthly, N would be 12. Once per month, 12 months in a year. N is equal to 4. Okay, there is no N in the continuous version of the formula. Okay, so basically what we have to do, we have 4 problems here, A, B, C, and D. And so what we're doing is we're taking our our given values and we're plugging them into the formula, right? So we could do this a couple, well, I'm going to do this a couple different ways. Some of you may prefer the TI-84 graphing calculator. Some of you, like me, might prefer the Desmos graphing calculator. This is just 2 options. There's other ones out there, but these are 2 very commonly used graphing calculators. One is online and one is, usually this is a handheld physical calculator. Okay, so what we have to do is plug in the specific values that are given in the problem into the formula. All right, so let's start with the graphing calculator, and we're going to type it in exactly as we see it. Let me move this over here. Right, exactly as we see it. So what I'm basically doing is this black formula here. I'm going to be typing the right-hand side into the graphing calculator. So instead of P, that's going to be the number 4,500, parentheses, 1 plus R over N. So R, interest rate, 0.073 divided by N. Now for part A, B, and C, the only difference is we're using a different value for N. Compounded annually, I would type a 1. Compounded quarterly, I would type 4. And compounded monthly, I would type 12. So I'm going to start off with over 1 because that's annually. Close parentheses. Now I need to raise it to the power of N times T, right? 1 times 11. T is 11. All right, and if I hit enter, that should give us the answer. We round that to the nearest penny, so it looks like $9,768.09. Right, 9,000. Let me write this down so I don't forget it. 9768.09. Now, we're going to do the exact same thing for part B and part C, but let me show you a little trick. Rather than retyping in the entire formula with just a different N, over here above the enter key, you see in blue the word entry. So if you hit second enter, that'll type in, that'll copy the last thing you typed. And now I could use these arrow keys to go back and change the 1, which was compounded annually. Now I could change that to a 4. And let me go back over, change that one to a 4. And we get a slightly different, slightly larger number, larger because interest is compounded more often, 4 times in a year instead of once. And then compounded monthly, I'm going to do the same thing. Second enter for my previous entry. And wherever there's a 4 for quarterly, I'm going to change that to a 12. Well, if I change the 4 to a 12, I'm going to type over one of my symbols. So let me just redo that. 12 times 11. And you could also insert an extra character. Let me show you how to do that. So same thing down here for this 4. Over. If I want to change this to a 12, well, if I type 1, 2 for 12, I'm going to type over that parenthesis. So if I type the 1, and now I want to insert a 2 to make the number 12, right? Insert is INS above the delete key. So if you hit second delete, that will let you insert another character. Okay, we get a slightly higher number because, again, the faster compounding takes place, or the more compounds per year, the faster the current balance is going to grow. 62 cents. Okay. And if we are going to compound continuously, actually, let me come back to that. So while we could see all 3 of these on the screen at once, let me come over to Desmos. And with Desmos, we're going to do the exact same thing. I'm going to type in exactly as it's written on the paper. P, parentheses, 1 plus, R over N, so 0.073 divided by 1. Oop, I hit comma 1. No, I want divided by 1. And I'll hit the right arrow key to get the cursor over to that parenthesis, close parenthesis. Raised to the power of 1. Oop, let's put the exponent in parentheses because I want n times t all to be the exponent. So 1 times 11. And if you look over to my graphing calculator, that's the same 9768.0855. It's just showing a couple more decimal places, but if we round to the nearest penny, we get the same number. It's easy to change these ones to a 4. I'm just going to use my mouse to select the 1, make that a 4, select this one, make it a 4. And there's my second answer, compounded quarterly. And now if we want compounded monthly, I'll change those 4s to a 12. I like Desmos much better than I like the graphing calculator. And then you see the third answer on the calculator, same number we have over here. Okay, and now for the fourth case, the compounded continuously, it's the same P, same principle, 4,500, the same rate, 7.3%, same time, 11 years. There's no N because we're not compounding at specific intervals. It's compounding continuously. So there's a little bit of math that goes into play between this one and this one. And what happens is, as the number of compounds per year goes to infinity, and we need a little bit of algebra to rearrange some stuff, and we use the definition of the number E, we get this second formula. A equals P times E raised to the RT. Okay, so on the graphing calculator, you see that in blue, E to the X over the ln key. So we're going to need that. So we'll do P 4,500 times E, so second ln raised to the power of R 0.073 times T, which is 11. So all these numbers are all given in the problem, right? They're all given in the problem. PE to the RT. And so we get an even larger number, $10,045. And if we're doing that on Desmos, let me just add another line. So same thing, 4,500. E, I'm using just the E on the keyboard. E raised to the power of, so caret, shift 6, in parentheses for the exponent, R, 0.073, times T, which is 11. And there's our $10,045.02. If we round to the nearest penny, that would be and 2 cents. Okay, so you've seen it done two ways, once on the graphing calculator, once on Desmos. So we just did 8 problems. We did four problems. Each one we did it twice, once on Desmos, once on the graphing calculator. So the last one down here deals with another quantity called the annual percentage yield. So the annual percentage yield, this is the actual interest rate that you pay or earn over the course of a year. So obviously, these different accounts, they have different interest rates if you consider the starting amount and the ending amount. They all have the same starting amount, 4,500. Right? They all start with 4,500, but part A, B, C, and D ended up with different ending amounts. Well, how could that be? They all have 7.3% interest. Well, it's because with compounding, interest is charged interest. Right? So the annual percentage yield tells you exactly what happens at the end of the year. And the formula for that is, I'll say APY for annual percentage yield is equal to 1 plus R over N. Okay, so it's the same 1 plus R over N that's in the formula above. No P out front, right? Just 1 plus R over N to the power of N minus 1. 1 plus R over N to the N minus 1. And I'm just going to do this for one case. Let's do compounded monthly. Okay, so I'll go over here to Desmos. I'm not going to do this twice. Let's just do it over here on Desmos. I'm just going to type in exactly what I just wrote down in blue. Parentheses. 1 plus R over N. So 0.073 divided by 12. I'll use the right arrow key to move the cursor. Close the parenthesis. Raised to the power of N, so to the power of 12. Minus 1. So because of the compounding, that 7.3% is a little over 7.5%. And that's 7.5%. That answer over there on Desmos on the top, 0.07549. So if we write that down as a percentage, if we multiply that by 100, oh, we're all too many parentheses. 1, 2, 1, 2. Okay, so if we take that, that is the APY. And if we convert that to a percentage by multiplying by 100, well, that's about 7.55%. If we round it, let's say to two decimal places, 7.55%. Right? So the more compounds per year, the higher the APY becomes over the interest rate. So we're stating an interest rate of 7.3, but with the compounding, that's what's that's what this formula down here does. It takes compounding into account. All right, that's it for this video. I hope this was helpful. Whether you're using the TI-84 or Desmos, doesn't really matter. Maybe it matters a little bit. I think Desmos is easier to use, but to each his own. Okay, that's it for now. Hope this was helpful.